Hello there. Thanks for coming in today. It is great to meet you. I have had a chance to look over your portfolio and your experience from this past year, and I think you have a really solid foundation. How are you doing today?
I'm doing well, thank you. I really appreciate the opportunity to interview with you. I've been following the work your studio does for a while now, so I'm very excited to be here.
Glad to hear it. We like to keep these conversations pretty natural, so we will just dive right in. Since you have been in the industry for about a year now, you have likely encountered a lot of the standard lighting and rendering pipelines. Let us start with something fundamental. In your experience, could you describe the difference between ambient occlusion and global illumination?
Sure. So, from what I have seen in my projects, both are used to simulate how light interacts with surfaces, but they really serve different purposes. Ambient occlusion is basically a shading method. It darkens those areas where surfaces are really close together or where light would have a hard time reaching, like in tight corners or crevices. It creates that illusion of soft shadows and depth by simulating how ambient light gets blocked in real life. The key thing for me to remember is that it doesn't actually account for the color or the intensity of light bouncing off surfaces. It is just focusing on the general darkness caused by obstruction.
That is a good way to put it. And how does that differ from global illumination in a practical sense?
Global illumination is much more advanced. Instead of just darkening corners, it actually calculates how light bounces off multiple surfaces in a scene, which affects both the color and the brightness of other objects. It simulates indirect lighting. So, if you have a bright red wall and a white floor, the light reflecting off that wall will actually cast a red tint onto the floor. That is color bleeding. It gives you those softer shadows and a much more natural look overall because the light is interacting with the whole environment. While ambient occlusion is a simpler, faster way to add depth, global illumination is the more physically accurate solution, though it definitely requires a lot more computation time.
Right, the render times can certainly be a pain. Moving over to geometry and simulation, I want to talk about how we handle movement and deformation. You have probably worked with both mesh-based and voxel-based systems. Can you explain the core differences between them and tell me when you would choose one over the other?
Yeah, there are two very different approaches. Mesh-based deformation is what I use most for character work. It works by altering the positions of vertices and edges on a polygonal mesh. It is ideal for surface-level details like character animation or cloth simulation because you have a lot of precision and control over the exact shape. It is computationally efficient for large-scale deformation, but it really struggles when you get into complex internal interaction, like if something is fracturing or if you are doing fluid dynamics.
And where do voxels come in?
Voxel-based simulation is different because it divides the space into a 18D grid of small cubes or voxels. This allows for much more detailed volumetric calculations. I would use this for things like smoke, fire, or liquids where the internal behavior of the volume actually matters. The downside is that it can be incredibly memory intensive and is generally less efficient if you just need a simple surface deformation. So if I need fine control over a character's skin or a piece of clothing, I go mesh-based. If I am doing an explosion or a liquid flow, I go voxel-based for that volumetric accuracy.
That makes sense. Speaking of smoke and fire, let us get into a more specific scenario. Imagine you are tasked with integrating a procedural, infinite element like a smoke plume into a shot with a fixed camera perspective. How do you handle that so there are no visible seams or obvious repetitions.
That is a tricky one, but the process usually starts with making sure the procedural system generates the element in a way that accounts for the camera's fixed viewpoint. I want to ensure the simulation or the texture generation aligns with the camera's frustum, so we do not see any hard edges or obvious styling. I usually use a combination of noise-based algorithms like Perlin or Whirly noise to create those natural-looking variations so it doesn't look like a repeating loop.
Once you have the noise set up, how do you handle the actual rendering to keep it seamless?
I would render the element in layers or tiles and then use very careful blending at the edges to maintain continuity. Shaders are huge here. I would use techniques like seamless tiling, edge fading, or dynamic texture offsetting to hide the transitions. Also have to make sure the system dynamically adjusts the density and the level of detail based on the distance from the camera. If the smoke is far away, it doesn't need the same resolution as the smoke right in front of the lens. Finally, I would use post-processing effects like depth-based blending or motion blur to help mask any remaining seams and make it feel integrated into the plate.
Let us talk about lighting again, specifically H-dress. For someone at your level, it is easy to just drop in any H-dry that looks okay. But why is proper H-dry usage actually critical for a realistic environment?
Well, the main reason is that a high-quality H-dry provides a full 360 degree representation of real-world lighting. It captures all those subtle variations in color, intensity, and direction that you just can't get by placing a few area lights. It is what creates those natural-looking reflections and accurate shadows. If the H-dry is mismatched with the scene, the illumination across the surfaces will feel off and the whole thing looks flat or unnatural. It basically anchors the CGI object into the environment by ensuring the lighting is consistent with the intended mood and setting.
Very true. Now let us pivot to rigging. Say you are working on a creature with a lot of articulated joints, maybe something with a complex spine or a lot of tentacles. Besides the usual joint limits, what is a common technical problem you might run into and how do you solve it?
One of the biggest headaches I have run into is joint flipping, or what people call gimbal lock. That is when the rotation axes of multiple joints align in a way that causes the joint to suddenly twist or snap unpredictably. It happens because Euler rotations, which are the standard, can become ambiguous when two of the axes overlap. To solve this, I would switch to quaternion-based rotation. Quaternions avoid gimbal lock because they represent rotations in a more stable mathematical way. Also try to be very intentional about the joint hierarchy and the rotation order to minimize the chance of those axes aligning in the first place. If that still doesn't work, I might use constraints or custom attributes to force the joints to behave better in those problematic poses.
Good. While we are on the topic of rigging and scene organization, let us talk about basics. What is a null object and in what specific scenarios would you use one?
A null object is basically an invisible, non-rendering placeholder. It doesn't have any geometry or visual appearance, but it acts as a control point or a reference for other objects. I use them all the time to organize my scene. For example, if I have a complex group of objects, I can parent them all to a single null object. That way, I can move, rotate, or scale the entire group as one unit without messing up the individual transformations of the objects inside. In rigging, they are also incredibly useful as handles for complex animations or deformations, allowing me to control a group of joints from one central point.
Now, let us talk about optimization. We are seeing more and more VFX work moving into real-time engines for virtual production or games. If you have a complex geometry model that is dragging down the frame rate, how do you optimize it without completely destroying the visual quality?
Optimization is all about balance. I start by simplifying the mesh, which means reducing the polygon count as much as possible. I look for hidden or overlapping geometry that the camera will never see and just delete it. I also merge vertices to get rid of redundant polygons. Then I rely heavily on texture baking. I can take all those high poly details and bake them into normal or displacement maps, then apply those to a much lower poly version of the model.
And what about the way the engine handles the object at a distance?
That is where LOD, or level of detail, systems come in. I would create a few versions of the model where the one closest to the camera is the most detailed, and as the camera moves away, the engine switches to simpler and simpler versions. I also look at the UV layouts to minimize texture size and use efficient compression formats like BCSAR. Finally, I try to avoid too many draw calls by batching similar materials together. It is basically about stripping away everything that doesn't contribute to the final pixel on the screen.
Let us move into something a bit more specialized. Performance capture and deepfakes are becoming huge. When you are dealing with facial performance capture, you are capturing the movement of the skin and muscles, but what non-visible data points are you looking for to make a performance feel human?
This is the part that separates a robotic animation from a real performance. Non-visible data points are the subtle, underlying elements like acting intent. That is the emotional or psychological motivation behind the move. Then there are micro-expressions, those tiny flickers in the face that happen too fast for us to consciously notice, but that the brain recognizes as authentic. I also look for things like breathing patterns, the moisture levels in the eyes, and even that slight tension in the jaw or neck that happens when someone is stressed or excited. To actually capture these, you need high-frequency motion tracking or even machine learning models that can infer an internal emotional state from external cues. The goal isn't just to move the mesh correctly, but to replicate those imperceptible nuances that make a person feel alive.
That is a very nuanced answer. Let us shift gears to environment work. Can you explain what a scatter system is and give me some examples of where they are most useful in a VFX pipeline?
A scatter system is essentially a tool used to randomly distribute objects or particles across a surface or within a volume. Instead of me manually placing 10,000 individual pebbles on a beach, which would be impossible, the scatter system does it for me. It is most useful in any environment where you need organic variation, like grass, rocks, debris, or even crowds of people. By adjusting the density, the scale, and the randomness of the distribution, you can create a scene that feels natural and believable. It saves a massive amount of time and allows for a much more organic look than manual placement ever could.
Quick question on lighting technique. If you have a subject that is blending into a dark background and you need to separate them visually, which type of lighting do you use?
You would use rim lighting. You place the light behind or slightly to the side of the subject, which creates a thin, bright outline along the edges. It defines the subject's silhouette and makes them pop against the background, which adds a lot of depth and dimension to the shot.
Correct. Now let us compare two different ways light interacts with materials. Can you differentiate between subsurface scattering and simple diffuse lighting?
Yeah, they are very different. Simple diffuse lighting is basically when light hits a surface and scatters evenly in all directions. This makes an object look flat and matte, like a piece of paper or a painted wall. It doesn't account for any light actually entering the object. Subsurface scattering, or SSS, is for translucent materials. It simulates light entering the surface, bouncing around inside the material, and then exiting at a different point. This is what gives skin, wax, or marble that soft, glowing look. If you use simple diffuse lighting on a human face, it looks like plastic or stone, but SSS gives it that organic, fleshy feel because light is traveling beneath the surface.
I want to give you a scenario. You are working on a heavy scene. You have a high-resolution character, a complex explosion simulation, and detailed environmental effects all in one shot. How do you manage the performance budget and the artistic intent so the scene doesn't crash and still looks great?
The first thing I do is prioritize. I ask what is the most important thing in the shot. If the focus is on the character's emotional reaction, then the face needs the highest detail. The explosion in the background can be simplified because the viewer's eye isn't focusing on every single spark. I would use LOD techniques for the environment and optimize my textures and shaders without sacrificing the overall look. I think it is really important to collaborate with the director and the technical directors early on to set hard limits like a maximum polygon count or a specific texture budget. I would also use profiling software to find the exact bottlenecks. If the simulation is the problem, I might cache it out or reduce the resolution of the solver. It is all about balancing the creative vision with the technical reality of the hardware.
Let us go back to character work. Imagine you have finished an animation, but the character's face looks stiff and robotic. What 3 technical or artistic adjustments can you make to improve the emotional range?
First, I would look at the timing and spacing. Robotic movement often comes from linear transitions. I would refine the curves to create smoother, more organic transitions between expressions. Second, I would add secondary motions. In real life, faces aren't static. There are tiny eyebrow twitches, slight cheek tremors, or lip quivers. Adding those micro movements breaks up the stiffness. Third, I would slightly exaggerate the key poses. Sometimes a realistic movement looks stiff on screen, so pushing the expression a bit further helps the emotion read more clearly, especially in fast-paced scenes.
In terms of the final stage of the pipeline, which software suite is the industry standard for compositing these VFX shots?
That would be Nuke by Foundry. It is the standard because of its node-based workflow. Unlike layer-based systems, the node graph allows you to see the entire flow of the image and make complex changes without having to dig through 100 layers. It is incredibly flexible for keying, tracking, and color correction, and it handles high-resolution plates very efficiently.
Let us touch on the math side of things for a moment. In your work, you hear the terms solver and simulation used interchangeably, but they aren't the same. What is the difference?
Write a solver is the actual mathematical algorithm. It is the piece of code that calculates how an element should behave based on physical rules, like gravity or collision. It takes the input data and produces the updated state for a single frame. A simulation, however, is the broader process. It is the act of running that solver over a sequence of frames to generate the final motion. A single simulation might actually use multiple solvers, for example, one for the fluid movement and another for the particles within that fluid, to get the final animated result.
Got it. Now back to rigging. What is the primary purpose of an armature?
The armature is essentially the digital skeleton. Its purpose is to provide a framework of interconnected bones and joints that allow an animator to control and move a 3D mesh. Without an armature, the character is just a static shell. The armature defines how the arms, legs, and spine bend and twist, turning a static piece of geometry into something that can be posed and animated realistically.
Animation principles are just as important as the technical side. Can you describe the concept of squash and stretch and tell me where it is most effectively applied?
Squash and stretch is used to give objects a sense of weight, flexibility, and life. You exaggerate the shape of an object, squashing it when it hits a surface or stretching it when it is moving at high speed. It makes the movement feel more dynamic and energetic. Even if the object is something rigid in real life, a bit of squash and stretch can make the action feel more impactful. It is most effective in character animation, especially for things like jumping or bouncing, where the deformation emphasizes the energy and force of the movement.
Beyond just making a shot look polished or visually appealing, what narrative purpose does exceptional visual styling serve in a project?
I think visual styling is a tool for storytelling. It reinforces themes and emotions without needing dialogue. It is a visual language that guides how the audience feels. For example, if you use a dark, desaturated color palette, you can subtly convey a character's inner turmoil or a feeling of hopelessness. Or if you use exaggerated, fluid animation, you can emphasize a sense of freedom or even chaos. The styling choices shape the emotional journey of the viewer, making the narrative more immersive by aligning the visual with the core message of the story.
Let us try a complex workflow scenario. You have a photorealistic virtual camera pass, but the background plate is a stylized, painted environment. How do you integrate the two without creating a visual discrepancy?
That requires a lot of matching in terms of lighting, color, and perspective. First, I would analyze the painted background to figure out the dominant color palette, the direction of the light, and the overall mood. Then, I would adjust the virtual camera pass to match those elements. This means modifying the T&D lighting setup and color grading the pass to align with the stylized aesthetic. I would also adjust the depth of field to make sure the focus feels consistent. In compositing, I would use edge blending, atmospheric effects like fog or haze, and maybe some subtle distortion to soften the photorealistic elements. The goal is to make the virtual elements feel like a natural extension of the painted world rather than something just pasted on top.
Last question for you. When you are rigging a complex character, there are two terms that often get confused: binding and skinning. What is the actual difference between the two?
Binding is the initial step. It is the process of connecting the character's mesh to the skeleton. Binding basically tells the software, okay, this group of vertices is influenced by this specific bone. It creates the primary relationship between the geometry and the armature. Skinning is the refinement process that happens after binding. That is where I go in and adjust the weights. I fine-tune how much each bone affects the surrounding vertices to ensure that when a joint bends, the mesh deforms smoothly and doesn't collapse or stretch in an unnatural way. So, binding creates the connection, and skinning makes the movement look realistic.
That was a very thorough explanation. I think that covers everything I wanted to go over today. You have a great handle on both the technical and artistic aspects of the pipeline, especially for someone with a year of experience. Do you have any questions for me about the team or the current projects we have going on?
I actually do. I saw that your studio is starting to integrate more real-time rendering into the final delivery. I am curious if the artists are being asked to handle more of the technical optimization themselves, or if there is a dedicated technical art team that handles the bridge between the high-poly assets and the engine.
That is a great question. We actually have a hybrid approach. We have a core team of technical artists who set the budgets and the pipelines, but we expect our VFX artists to have a strong understanding of optimization, much like what we discussed today. We find that when the artist understands the technical constraints, they make better creative decisions from the start.
That makes a lot of sense. I prefer that approach because it gives the artist more control over the final look.
Definitely. Well, it was a pleasure talking with you. We will be in touch regarding the next steps very soon. Thanks for coming in.
Thank you so much for your time. I look forward to hearing from you.